So this is our Denver Hackathon project with the Ant Alpha team, and basically who is hacking together is me, Lance, Richie, Fedor, and having the mentorship of Jason, which would not be possible if not. And our project name is Hunter Z Hunter. If anyone watched Hunter x Hunter, yeah. And the idea is that our project is about my scavenger hunt game empowered by zero knowledge proof and machine learning algorithm. So how does it work? It's basically it's like a treasure hunt. Like, we will give you some hints. You have to find the object, take a picture. If that picture is the right object, you will get a reward from the smart contract with the ZKML verified. Yeah. So for the zero knowledge proving system, we're using Hello 2. For machine learning model, we're using a 4-layer convolutional neural network, which Lance knows what it is. I don't know too much. And definitely is a typo empowered by EZKL, which allow us to have built this, even though we are new to both machine learning and ZK. So how the scavenger hunts work? So basically, we will have a demo, but some user comes, creates the hunt. It's like the bounty, and then like he uploads the image of what the target image is. He puts the bounty of how much reward, and he have a description for the users to try to figure out what the item is. And then he adds the hunt to Hunter Z Hunter smart contract with the encrypted image data. And then once we have that, how does it work? I'm a hunter now. I want to see like, oh, there's a tip here. I'm going to get the item. So I find the object. I submit the picture. The model will first verify. We will have a verification mechanism it will tell you if that image is correct or not. If it's wrong, based on the machine learning model, if it's wrong, it will just return incorrect image. If it's correct, then it will generate the proof. Then it will run the ZKML, generate the proof, and then send the transaction, which will be, the proof will be verified on chain, and then you will get the reward. So here is a very important step. We are not generating proof for every submit. We are only generating proof for the submits that have passed our first checkpoint, because it's expensive. So how our journey started. So we came here. I came a little bit late. They already had the idea. And we were like, hey, let's do it. This is an amazing idea. I think we can do it in a few days. Yes. We first started creating the ML model, which was done by Lance with the mentorship of Jason. Good, it's working. And then we were able to compile it to Halo 2 circuit, and we were very excited because it was the first time we have done something like this. We generated a proof, yes. Verified locally, yes. And then we went to deploy the verified contract, but something happened. We had 109,000 lines of Solidity codes. And our question was, how can we reach this success line? We want to get there. How can we reach it? Basically, the Solidity code had 5 megabytes, and the limit is 24 kilobytes. So at the moment we saw this, we were like, we need like a few 100,000x optimization. It was interesting. And then we started to improve. I'm just giving like a short, like about the challenges that we went through, but some improvements, like, okay, where do we start with, right? So the first thing is that Dante, who is Jason partner on EZKL, he implemented something that we can print out a PNG version of the circuit. This is like a matrix. I don't know the very details. If anyone is curious later, please ask Jason. And what you're seeing here is basically on the circuit, there is the instances, which are the inputs, the advice, which is the computation that is done in the middle, and the constants. And here, what we want basically is to have much less red line. This is the first image. We want the much less red line and more green. Like, we want to be all green if possible. Red line is basically inefficiency. And then we were tackling here and there, and we were able to, yay, we got this first optimization. If you can see here, like here is one column, 2, 3, 4, and here is 5. Basically, we were generating this extra column for no reason. And then we were able to take that out by optimizing one line of code. And then Dante also helped us. We were able to optimize like this, and now the state is like this. So we came from here to here. It doesn't seem that much big of a deal, but it's like a very, very big memory improvement given the size of the computation. My computer was like, I'm not gonna work anymore, like 4 times, like too hot, I'm not gonna work, you figure out yourself. And yeah. So the result was, it was not only that, we had a lot of other challenges. We've been here like for almost a week now. We were able to deploy a model. Actually, it was this morning. So we were able to, not only with the optimization, but with a mechanism that is unique to EZKL. And I think that's why EZKL is so special, is that it's have the power to allow bigger machine learning models. For example, you can create small machine learning models and compile to Circum and have a very short, very compiled verification contract, but there is a limit for Circum. So there is a limit of how big of a circuit you can do on hands. You will see a lot of machine learning models out, ZK machine learning models out there, handwritten by many people. But when you're gonna try to build like, oh, let's now do the real deal machine learning models that do a lot of things like image recognition, like, or very precise image recognition, Circum has a limitation, so it needs other kinds of solution. And I think that's where EZKL comes in, because it has these features that will compile really big models into 21 kilobyte size. We went from 5 megabytes to 21 kilobytes. And we were able to deploy locally. We're still working on deploying like on a testnet, but this is Remix. And I created a contract to deploy bytecode, and then I deployed the bytecode to the contract. And now let's demo what we have prepared for today. I think Rich can. Maybe you want to share your screen, Richie? Yeah. Yes.
Wow. Okay, so there's only a few simple steps here. We're going to first go and we're going to create a hunt. And we're gonna search for a it's sitting over on that table, and it's right with me, but it's just a little green packet of chocolate.
I almost ate that chocolate a few times. I was like, oh, we're using that. That's okay. Maybe we can. By the way, the focus is for this to be mobile. Yeah. So our goal by the end of, we have 3 more days to have it mobile, fully working with the smart contracts verifying, and yeah.
So, yep, and we just set the time when the hunt is going to end. So we can set that up for a few days, just in case people need a lot of time. And the prize money. So
very cheap.
Yeah. So this is in Ether, and then if this were on mobile, we would take a picture of the item, but this is the item right here that we're gonna let people search for. So this takes a few seconds, and what it's doing is it's going and running that picture through the model, and in order to generate a signature of sorts. And then it's storing all this data on chain. All of our data is stored on chain. We don't have a database for this app. Okay, so now it's showing at the top of the list here, our chocolate hunt. Ends in about 5 days. And so now this is a URL that this is going to click on submit photo. This is a URL, a friendly URL that we can send to our friends. And the idea was to make this as easy as possible. Just share, you can send it to your kids or your friends or whoever, and they can just play. It's frictionless. There's no wall pay. We're paying all the transaction fees.
On testnet.
Yeah, nibble on testnet riches. Okay, so I'm gonna again, though I'm taking a picture with my phone here, I'm gonna submit a picture of the wrong object. And the idea here is, to try to find the object, but more than anything, you're just trying to get the machine learning entity to say yes, right? You want to get a yes back. And so, yeah, this takes a few seconds.
Yeah, let's demo effect.
This is
normally it's faster. Yeah, so I think something went wrong. I think yeah.
Let me make sure this is running.
I think the server is still running. Try the phone image, yeah. This is the suspense moments of every hackathon demo. The transaction. I think it's
okay. So
there's some error going, I think.
Yeah, but this did tell us that it failed. Let's go ahead and try the right object here.
So maybe you can raise some questions.
Yeah, anyone have any question? And until here, yeah.
Why you chose AHH for this project?
So it was because it was already ready by EZKL. We didn't build any compiler or any either from the ZK machine model to the circuit and circuit to smart contract, because that would take a lot of time. So we are using the library EZKL, and the library EZKL implements that for Halo 2. Basically, on EZKL, what you can do, you input your Onyx model, you will get a Halo 2 circuit, and then you can generate a solidity contract directly from that. We didn't implement that ourselves. Some people do it manually, but like I mentioned, even if you do it manually, it's really hard to do for really big models. So you need to have a really good mechanism with really good cryptography primitives and techniques to be able to condense big models into smaller verifier contracts and not have 5 MB solidity code.
Oh, it's ZKL.
EZKL. Yes, easy of easy, but yeah, it wasn't so easy.
Yeah, okay. So yeah, so this is showing that this one failed. There we go.
Yeah.
Yeah, so let's try again. Let's submit the right photo.
Which is
So you'll see this is
the same.
This was the original that we submitted here. This is a picture of the same object, but it's a different picture, right? So the app should be smart enough to recognize that it's the same object.
Anyone have? Oh, yes. So, yeah, so what will happen now is that our server will generate a proof with this image because it was already pre-verified. The proof takes, depends, but 20, 30 minutes. And then once the proof is generated, the user can expect a reward in around 30 to 40 minutes. We will not generate proof to any image. For example, the other one failed, we're not generating the proof for that. But this is done automatically. The user don't need to wait. That's why he had the address, just in case that it's a right image. That's what happens. And now to finalize, I can share the last slide. So to finalize, what is the next steps, right? Why we're so excited about EZKL, why we were so excited about machine learning models is because I think what we have built here, more than the game itself, it's I guess one of the first image recognition model on chain. So now you can have applications around image recognition. One idea is to integrate for account abstraction, for example. Oh, you can only send a transaction if you send from the right address, and also you have the image, right? So even though if someone steal your private keys, they have a picture of you, then we have to make it safer, but that's one of the use cases. We have image, like, I think this can unlock many other possibilities with image verification. It's basically giving eyes to Ethereum, right? Like now you can build applications that depend on visual data and be decentralized. And so IoT stuff, things about credit carbon, like you can make sure that the tree is growing and all that. And also in terms of EZKL itself, like we can now have further powerful machine learning models to empower the next generation of smart contracts, basically making smart contracts smarter. So that's the thing I think I'm very excited about, more than what we have built. Yes, it's 100% open source. You find a lot of bugs, but it's there.
They built some of them, especially fixing bugs. And
Yeah.
Okay. It's hunter-z like -hunter. Hunter-z.
Yeah, we can share the link on the Ant Alpha chat, so if anyone wants to check it out. It's still work in progress. We still have 3 more days for the final presentation, so we'll work hard.
So what kind of optimization that you expect you can do with this kind of machine learning model to maximize content?
I think one is on aggregation, like how we can aggregate bigger models into smaller ones. I think like that's one optimization. Aggregation is one, like also adding that's more for JSON part of it. Like I would say like adding more cryptography techniques that helps you like condense stuff into 24 kilobytes or even less. The other one would be also to optimize how the model runs. Like we saw before, we were using a lot of memory. Now we are using much less memory. You can see on this image. This is like the kind of optimization you want to do. And sometimes each model is very specific. So because we optimize to this one, it doesn't mean this optimization will reflect on the other ones. And sometimes like putting other models, you see like, oh, in this model, this weird thing starts to happen. In this model, other weird things start to happen. And basically testing out and making sure all models can fit. And I think that
one that was really cool that we were working with Jason on was being able to take the output tensor of the machine learning model and roll it into one value, kind of like slot packing in Ethereum, where you can, rather than produce a bunch of 64-bit floats, you roll them all into one integer. That was one thing that we were really excited about, because the output of the tensor, or the output of the machine learning model, it greatly affects the size of the verifier. So if you can make that, our output tensor was 10 elements. If we could roll that up into one element, then that'll lower the verification size as well.
To take an example that I guess everybody would understand, if we're talking about text-based AI, like ChatGPT, for example, these are pretty huge, I guess, the models that they are creating. So do you think that at one point we could have the optimization required to be able to put these types of model on chain? And because I guess this would be incredible, because one problem with ChatGPT today that is closed source, that it's totally biased. Like when you use it a little bit, you understand that it's not really open and it doesn't think for itself. So imagine having ChatGPT on chain could really like gather information from everywhere and we have like a learned bias now.
You want to answer that?
For
Nice.
example,
Yeah,
would we be able to do that?
Yeah, for sure. So, EZKL is mostly used for model running. So when you already have a model, a machine learning model that takes in the input and spits out an output, you can put that on chain and it acts as the verifier on chain, right? But then you have training, right? So model training, if you have a model and you can train it with data, the data that ChatGPT was trained on, it was like large text, large language model. And like basically the large language model is what makes ChatGPT able to answer questions so effectively. So it's this thing called federated learning where you can basically train data on multiple people's devices. And I think ZK can be used for that, where if you can train a little bit of data or train a machine learning model with your own data and then contribute that to a greater model. And that greater model is kind of like acts as a swarm intelligence rather than a centralized entities intelligence like OpenAI, Microsoft. But I mean, anything's possible. That's definitely possible.
Yeah.
So it would be possible to reduce the size of the model, to put it on chain?
Eventually, yes. I think the question more than if it's possible, if why will we do that, right? I think like just because we can, it doesn't mean we should. And for example, what would be the use case of having a ChatGPT model provable on chain?
Any type of AI model that's like bigger than a large model.
Yes.
I think those are gonna come naturally as the space becomes more innovative. Like I think we're gonna be able to put much larger models on chain for sure.
Yeah. That's
This stuff is still really new. So I think it's just a matter of time until we have like super large models on chain that could do things like account abstraction, that could do a Face ID recognition.
Thank you, guys.
I'm clapping for myself. Thank you. Yes. Finally.
Hey, Luke, got to know what you're working on.
All right.
You have the whole week to prepare amazing presentation.
Yeah. Let me get my keynote first.
Yeah, there's Lance. The guy is coming back. Oh, you have to be better.
It's my keynote.